Hello, today we're going to learn about conic sections. And what conic sections are is if I put two cones vertex to vertex on top of each other and their axes lined up, there are four different cross sections I can get. If I cut through this horizontally, it would create a circle at any point along here, as long as it was parallel to the base. If I cut through horizontally but not parallel to the base, it would create an ellipse, which is like an oval, but in math we call it an ellipse. If I went through a side and I hit the base of the cone at the bottom, that would create a parabola. And if I cut through and hit the cone on top and bottom, so it kind of looks like two parabolas, we call this a hyperbola. So these are our four conic sections: circle, ellipse, parabola, and hyperbola. Now we'll start with the unit circle. We should all know what the unit circle is. It's a circle with a radius of 1. Its equation is just x squared plus y squared equals 1. Now if I stretch this out horizontally, say like this looks more like a football than an ellipse, but forgive my drawing. But that would be an ellipse because I stretch one side longer than the other side. Now unit hyperbolas, there's two branches. There's one branch over here and one branch here. Now I should separate these equations up a little bit more. If it's x squared minus y squared equals 1, it's going to open to the right and to the left. If it's negative x squared plus y squared, it's going to open up and down. Finally, we're going to look at unit parabolas. Y equals x squared is our basic parabola, and x equals y squared is now going to open up to the right. So we're going to use these and try to figure out which equation goes with which one. So if I was looking at a circle, there could be equations like 4x squared plus 4y squared equals 9. This would be an equation of a circle. Or 9x squared plus 9y squared plus 2x equals 4. I know this is a circle. Now for an ellipse, we would have something similar, but the coefficients in front of x squared and y squared are going to be the same sign but different values. Where a circle, you'd have the same value in front of x squared and y squared. So it doesn't matter how many x's, what numbers on the other side. If I have 10x squared plus 7x plus 3 plus 9y squared plus 3y equals 72. If you just look at the values in front of x squared and y squared, you can tell that this is an ellipse. So down here is an ellipse, and up here is a circle. Now when I look at my hyperbolas, there's one of the squareds is going to be a negative number. So if I have 4x squared plus 3x minus 5x squared plus 2x equals 9, since this is positive, this should have said y squared. I didn't want two of the same variables. Since this one is positive and this is negative, we'd know that it's automatically hyperbola. So, and with a parabola, one of the variables is squared while the other one is not. So I could have something longer like 3x squared minus 5y plus 3 equals 92. We automatically know this is a parabola because one of the variables is squared while the other one is not. So if we wanted to take a little notes on this, a circle, x squared and y squared always have the same equal coefficients if they are on the same side of the equation. Same with an ellipse. X squared and y squared have unequal coefficients, but the same side, assuming they're on the same side of the equation. And hyperbola, x squared and y squared have opposite signs, assuming they're on the same side of the equation. Where a parabola, only one of those two variables is actually squared. So let's go through some examples. This one, 3x squared and 2y squared are on the same side. One's positive, one's negative. So I know it is a hyperbola. X squared plus 6y, those are on the same side and they're both positive, but different sizes. One has a coefficient of 1 while the other one has a coefficient of 6. So we know that's an ellipse. Both of these have the same value, so we know that has to be a circle. Right here, x squared and y, there's no y squared around here, so we know this has to be a parabola. Now, no matter how many other variables, as long as there's nothing over and a squared, we just look at the squares, and they're both on the same side. The coefficients are different, so it's going to be an ellipse. Here, they're both on the same side. Coefficients are the same, so it's going to be a circle. Here, there's an x squared, but there's no y squared at all, so we know it's going to be a parabola. Here we have an x squared, a y squared, no other squareds. These are on the same side, so it's going to be a hyperbola. Now, if I had this one, this was written in standard form. So if I took, this would be like x over 5 squared, which would be x squared over 25. This would be y over 3 squared, would be y squared over 9. These two coefficients, we could figure out the rest of these, but it really doesn't help us out much because we're just looking at the coefficients on the squareds. This is 1/25 and 1/9, same sign. So that's going to be an ellipse. Now, this one, I don't want to sketch the graph quite yet. We'll do that soon enough. Since this x squared is going to be negative, this x squared is going to be positive, we automatically know that that is a hyperbola. All right, so now if we look at this, what type of conic section is it going to be? Well, the x will be squared plus a whole bunch of stuff. The y will be squared and plus a whole bunch of stuff will equal 16. Those have the same coefficient, so we know that this will be a circle. Now this is written in standard form for a circle. Standard form for a circle looks like this. X minus h squared plus y minus k squared equals our radius squared, where hk is the center of the circle and r is our radius. So if I go back to the previous problem, our center is at 2, 1, and our radius is the square root of 16, which is 4. So if I wanted to make a quick graph, I go 2 to the right and 1 up, and then I go 4 up, and I make a complete circle. And that is, so I could go 4 up, 4 to the right, 4 to the left, and 4 down, and that would be my equation. Now, if I want to graph this circle, x plus 2 means I go to the left 2, y minus 3 means I go up 3, and my radius is 7. So I'll just draw a quick graph. That's not the thing I wanted, but I'll roll with it. So that's the 0.23, that's my center. So I'm going to go up 7, to the right 7, to the left 7, and down 7, and then connect all of those points. Hopefully you can draw a little bit better than I can with this airliner, but that's a rough sketch of my graph. Now by this one, what conic section is this? This would be like x squared over 9 plus y squared over 16. They're both positive, but the coefficients are 1/9 and 1/16. So this is going to be an ellipse. Now, the standard form for ellipse looks like this, where hk, again, is still the center of the circle. A is the horizontal radius, how far you move horizontally, and B is the vertical radius, how far you move vertically. Now keep in mind that this right side is equal to 1. If it's not, we'll have to solve for that and we'll figure that out. But in order for this all to work, our right side has to equal 1. So if we look back at this problem I wanted to graph it. It doesn't move it to the left or to the right. However, our horizontal radius is 3. So there's going to be a point 3 to the left and 3 to the right. Our vertical radius is 4. And so here is our ellipse. All right, so here's another example. Our major axis, well, first let's sketch the graph and then we can talk about that actually. Our major axis, if I drew this, oh, same one. I thought I changed it. Our major axis is the longest axis in our ellipse. Our center here is 1, -2. So I go 1 to the right and 2 down. And now from here, I'm going to move to the right 3, to the left 3, and then up 4, and then down 4. And now I draw this. My major axis is my longest axis. So my major axis goes from down here to here, so that's 8 units long. My minor axis will go across here, which will be 6 units long. Now, if I want to name all my vertices, I start at the point 1, 2, 1, -2, and I go up 4 units. So one vertex would be 1 to the right, up 2. This vertex, we go 3 to the right from our center, so that would be 4, -2. Over here, we go 2 to the left and down 2, so -2, -2. And then this final point, we go 1 to the right, and we're going to go 2 down from -2, so that would be 1, -6. So those are our 4 vertices in this graph. Oh, I had a page for me to do it. I didn't, I guess. All right, so now if we asked what are the coordinates of the top vertex, we just have to look at this, and that's 1, 2, which is E right here. Now if we look at this one, since x squared is going to be positive and y squared is going to be negative, this is going to be a hyperbola. Graphing hyperbolas is a little tricky. Again, this is a little off. These are 2 unit parabolas, hyperbolas, which we talked about earlier. If the x is positive, it's going to break off in the x direction. If the y is positive, it's going to break off in the y direction. So here are our 2 equations for hyperbolas in standard form. This is if it breaks off in the x direction, and this one if it goes in the y direction. Now b divided by a plus and minus that value is going to be the slopes of our asymptotes. Now on this left-hand side, it's going to open right-left because the x is positive. Over here, it's going to open up-down because our y is positive. All right, to graph this equation, my center is 1 to the right and 2 down. And my asymptotes are going to be plus and minus b over a, which is 4 over 3. So I start at my point and I go up 4 over 3. And now I can draw a line through that, and that is my first asymptote. Then I can go down 4 and over 3. 1, 2, 3, 4 over 3. And my line through here is going to look like that. So those are the slopes of my asymptotes, which guide me in making my hyperbola. Since this is positive, it's going to open in the x direction. And my radius is 3, so I'm going to go out 1, 2, 3 from my center point. 1, 2, 3 from my center point. And I'm going to use this as my guide to get closer and closer to those asymptotes. So it's going to come here and get closer and closer to that asymptote. And over here, It's going to come up, get closer and closer to this asymptote, and in the opposite direction, get closer and closer to that asymptote. So this is a decent drawing of our hyperbola. Now, since we've done all the conic sections, there's going to be a couple graphs that we're going to do, and then we're going to do one more hyperbola. This is an ellipse. The center is at negative 3, 1. So it's going to be x plus 3 squared, y minus 1 squared. Now if I look at my radius, my x radius is 1, so I can put over 1, or I can leave it out. Doesn't matter. In my y direction, I'm going up 2, so I'm putting over 2 in here. And an ellipse is always equal to 1 on the right-hand side. So x plus 3 squared plus y minus 1 over 2 squared equals 1 is the equation of this ellipse. This hyperbola, our center point is 2 to the right, so it's going to be x minus 2. My y value is up 1, so it's going to be y minus 1. Both those are squared. Since my x is breaking off in the x direction, my x is positive. That means my y section is going to be negative. In the x direction, I go 1, 2, 3, 4 to the right. In my y direction, if I go 4 to the right, I'm going up 1, so that's a 1. And you really don't need a 1 if I just put y minus 1 squared, that would be fine too. And a hyperbola, like an ellipse, is always equal to 1. All right, here is a circle. First, I need to find the center of our circle, which is 4 to the right and 1 down. So that's going to be x minus 4 squared plus y plus 1 squared. And that's going to equal 3 squared, which is 9. All right. Now, this one, oh, and one thing I want to talk about here is circle is not equal to 1. It's equal to the radius squared. So that's why we left it like that. Now our last one is just one more hyperbola before we are done. Here we graph it. It goes 2 to the right and 6 down. So 2 to the right, 1, 2, 3, 4, 5, 6. Could have picked a little nicer number for myself, but oh well. So we went 6 down. And now our slopes of our asymptotes are up 3 over 5. 1, 2, 3, to the right 5. 1, 2, 3, 4, 5. And then down 3 over 5. 1, 2, 3, to the right 5. Now from here, you can just draw a line here, a line here. Now since our x is negative, our y is positive, so this is going to open up, down. We're going to go up this distance, 3, and down 3 from our point. And now we can draw our hyperbola. So we start here and draw this out to these asymptotes, start here, draw it out to this asymptote, and so on, and so on. And we're set. All right, hopefully that helps you do the homework for tomorrow's class. Thanks.